All right, so ladies and gentlemen, these notes cover Pythagorean triples as well as Pythagorean inequalities and geometric mean. Okay? So Pythagorean triple is a set of three non-zero whole numbers, which a, b, and c, such that a squared plus b squared equals c squared. And we call that a Pythagorean triple. One of the ways we know it's a Pythagorean triple is if we solve for it, there's no decimal. Okay, so we know, and I've mentioned this before in class, that 3, 4, 5 is a very common Pythagorean triple, because if I take 3 squared plus 4 squared, it's going to equal 5 squared. And we know that these are going to be A, B, and C, because C is always our biggest number. And these here, like it says in this box, these are the most common Pythagorean triples. So if I give you a right triangle, assuming I can draw one because it's been, spring break, and I tell you that this side is 5 and this side is 13, I automatically know this bottom side down here has to be 12. Because it's a Pythagorean triple. Okay, there's little to no math involved. I recommend memorizing at least the ones that are in this box. There are a lot more, but these ones will help save you a lot of time when you're working on things. Okay, find the missing side length, tell if the side lengths form a Pythagorean triple, or explain. Remember, in order for something to be a Pythagorean triple, it can't be a decimal when we solve for it, okay? So taking what I know, I'm going to zoom in here. I know that the side across from the right angle is automatically side C. So I always smallest side A and then B. So we're going to plug this into the Pythagorean theorem to see if we have a Pythagorean triple. So we have 14 squared plus 48 squared equals c squared. Okay, so I'm going to plug this into the calculator, so I'm going to skip this next step. So 14 squared plus 48 squared gives me 2500 equals c squared. And to see if this is an actual Pythagorean triple, we take the square root of both sides. Okay, and the square root of c squared is just c. The square root of 2500 is 50. So is this a Pythagorean triple? Yes, it is. Because it does not give you a decimal when you solve for it. Okay. Next one, find the missing side length. Tell if the side lengths form a Pythagorean triple. So let's go ahead and label our triangle. Side across is C. So I know that this could be A. So it looks like we're going to solve for B this time. So can't really skip steps for you here. So 4 squared. Oh, wow, that doesn't look like a 2. Neither does that. 4 squared plus B squared equals c squared. Okay, so 4 squared is 16 plus b squared equals 144. Okay, so to get b squared by itself, we subtract 16 from both sides. So b squared equals 128. Square root to get b by itself. And when I plug in the square root of 128, I get 11.313. So this is not a triple. Simply because it gives us a decimal here. Okay? All right, so to understand why the Pythagorean inequalities are true, consider this. All right, so we've actually talked about Pythagorean triples in a previous lesson, but they're important to know and to look at because they help us determine whether or not we have a right triangle. Okay, the Pythagorean theorem itself, c squared equals a squared plus b squared, this right here, is used strictly for a right triangle. Okay, because it tells me that measure C is 90 degrees. So if they are equal to each other, if C squared is equal to A squared plus B squared, then C by definition is 90 degrees. Okay. Second, if C squared is greater than A squared plus B squared, then angle C, or side C, has increased. Okay, so if side C has gotten longer, this tells me that angle C has to be 90 degrees or greater than 90 degrees. So then we have an obtuse triangle. Okay, because notice here that if side C gets longer, the angle across from side C is angle C. So if side C gets longer, then angle C has to get bigger. Okay, and if I look at this last inequality, if side C is less than a squared plus b squared, then side C has actually gotten smaller. Okay, so if side C gets smaller, then the measure of angle C is less than 90 degrees. Okay, and we have an acute, an acute triangle. Okay, so these are our three inequalities. Okay, we're used to C equals a squared plus b squared equals c squared, c squared equals a squared plus b squared. But we haven't really played a lot with the other ones. We did in a previous unit, but we're going to revisit them a little bit today, okay? Tell if the measures can be side lengths of a triangle. If so, classify the triangle as acute, obtuse, or right, okay? The biggest side has to be C. Okay, and one of the things we talked about a long time ago, I don't know if you remember this, is that in order for three sides to be a triangle, I need to pick any two sides, and they have to be bigger than the third. Okay, so if I label these, I labeled C, so this is A, and this is B. Is A plus B greater than C? Is B plus C greater than A? And is C plus A greater than B? Okay, if that is true, and we talked about this last semester, I think, maybe it was this semester, it's been a while. If these three things are true, we can have a triangle. Okay, 5 plus 7 is greater than 10. 7 plus 10 is greater than 5, and 10 plus 5 is greater than 7. So, y'all, yes, we can have a triangle. So now we need to figure out if it's right, obtuse, or acute. Okay, so we're going to see, is 10 squared, we're going to leave this blank, 5 squared plus 7 squared. Okay, so I know that 10 squared is 100. 5 squared is 25. And 7 squared is 49. So 5 squared plus 7 squared gives me 74. Okay, so the inequality that I'm going to write in that box is that 100, okay, 100 is greater than 74. Because I wrote greater, that means that this is an obtuse triangle. So yes, we have a triangle, but it's obtuse. Okay, so let's go ahead and look at this one. Label our sides, A, B, and C. we need to check to see if it's even a triangle first. Okay, so is A plus B bigger than 5 plus 8 is 13, bigger than 17, so yes, that's true. 8 plus 17 is bigger than 5, and 17, all right, so yes, we have a triangle. But now we need to figure out what type of triangle. So 17 squared, 5 squared plus 8 squared. Okay, so 17 squared is 289. Oh. Five squared plus 8 squared is 89. So greater than means obtuse. Okay. Greater. Whoa. Tell if the measures. Okay, so we're going to do the same thing. Woo. Let's label our sides. A, B, C. We need to make sure A plus B is greater than C, B plus C is greater than A, C plus A is greater than B. Okay, A plus B is 19. 19 is greater than 16, so that's true. 12 plus 16 is greater than 7, that's true. 16 plus 7 is greater than 12, so that's true. So yes, we have a triangle. Okay, so now we just have to see what type. 16 squared, 7 squared, plus 12 squared. So 16 squared is 256. 7 squared plus 12 squared is 193. Okay, 256 is greater than 193, so we have an obtuse triangle. Okay, so let's go ahead and look at this last one. A, B, C. Let's see if we even have a triangle. A plus B is greater than C. Is 11 plus 18 greater than 34? Correct answer is no, so not a triangle. Okay? All right. Hopefully that made sense this time around. Cool. Whoa. All right. Geometric mean. In a right triangle, an altitude drawn from a vertex of the right angle to the hypotenuse forms two right triangles. So if you're like, what? I don't get it. Look right here in theorem 8.1-1. The altitude to the hypotenuse of a right triangle forms two triangles that are similar to each other and to the original triangle. Okay, so if you look here, we have one triangle, two triangles, three triangles. See, so they're all like together and they're all in there, and they're all similar to each other. Okay, and one of the things that like I feel like I shouldn't have to say, but we're gonna say it anyways. Wow, I need a bigger eraser. Okay, maybe that'll work. Kind of, sort of. All right. One of the things that I feel like I need to say, but I shouldn't have to, if this is a right angle, then this over here is also a right angle, guys. Okay, so we have 2 right triangles, or 3 right triangles total in one picture. Okay, so the way that we use geometric mean is very similar to what we did for our Carmen Sandiego project, except these formulas make it a little bit easier, because I know cross multiplying was a little confusing for you, so we're going to look at it this way. If you look at the big triangle, okay, this big kahuna here, all right, we know that there are side lengths A, B, and C. Okay, so we labeled those. Okay, those have been labeled for you, A, B, and C. We also went and labeled the altitude. That's H. Okay, and the altitude takes your side C and breaks it up into 2 extra sides, side H and side Y. Okay, so the altitude cuts it in half. So we have side H, side Y. Okay, the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the 2 segments of the hypotenuse. What does that mean? So if I were to ask you to solve for side H, we could use this formula right here. H squared equals x times y. Or we can simplify that and say H equals the square root. I don't know how long that was muted for, so I don't know what you missed. So you'll have to let me know. I apologize. My hand must have hit it. Okay. Okay. So if I ask you to find the altitude, we can use h squared equals x times y, or h equals the square root of xy. Or I might give you some sort of thing that looks like this picture looking thing. And I might say, hey, I want you to find side A. Okay, which you could do, or find side B. And if I asked you to do those things, for side A, we would take a squared equals x times c, which is the same thing as a equals the square root of x times c. And if I asked you, oh hey, if I asked you to solve for b, we would take b squared equals y times c, or b equals the square root of yc. Okay. So let's go ahead and see what this looks like. No. Find x, y, and z. Okay. So let's figure this out. I'm going to go ahead and label my triangle with what I know. I know this is A, B. This whole thing here is C. If this is X, this is Y. And this is H. Okay. So from the slide before, these are the 3 formulas that we know. Okay, I'm just going to write them all here, and we're going to pick one. We're going to use them all to solve for things. Okay, so h squared equals x times y. We know a squared equals x times c, and b squared equals y times c. Okay, I can't really solve for a squared or b squared because I have no idea how long c is. Okay, so we're going to have to use first this h squared equals x times y. Okay, and in this case, I know it looks a little confusing. We're talking about this x and that y. Well, that x and that y. okay, in terms of solving for h. Okay, so I'm going to take what I know and actually just plug it in and see if I can solve for that missing x value. So h squared is 6. So 6 squared equals x, which I don't know, times y, which is 9. Okay, well, cool. 6 squared is 36. And 9 times x is just 9x. 36 divided by 9. Oh, okay. 36 divided by 9 gives me an x value of 4. Okay, so I know that this x value right here is going to equal 4, which means I also know that this c value is 13 because I took those two sides and I added them together. 9 times 4. Okay, 9 times 4 is 13, or 9 plus 4. I need more coffee. Okay, so now I can go ahead and solve for a squared and b squared. Okay? So to solve for a squared, x, which I just solved for, times 13. Okay, so 4 times 13 is 52. A squared equals 52. So to get a by itself, we square root that. And the square root of 52 is 7.2. So a 7.2. Okay, and that's that side. Okay, so to solve for b, we know that b squared is equal to 9 times 13. 9 times 13 is 177, so b squared equals, 117. So b, when I take the square root of it, is 10.82. And that's that side. Okay. Okay, ladies and gentlemen, we'll start class with this one tomorrow. All right, talk to you later.